All right, so I got data of all the upperclassmen. This is all the juniors and seniors. And we divided it up into two groups. This is athletes and non-athletes for the upperclassmen. And it's GPA data, right? So I've got all the GPAs of upperclassmen, juniors, and seniors who participate in some kind of sport versus ones who don't. And today, I have a sample of 40 students who are classified as non-athletes. And what I want to know, so by the way, there's 492 students that are classified as non-athletes. Notice I didn't say non-athletes, students that are classified as non-athletes. And what I want you to do is, with the people around you, try to figure out what do you think is going to be the GPA, the average GPA of all the 492 non-athletes. What do you think is going to be the average GPA of that population? So with the people around you, with no fighting, what do you think is going to be the average GPA of that population? Henry, welcome back. Thanks. Did you get a haircut? Yeah. Looking sharp, buddy. Thanks. I want to know, what do you think is going to be the average? The average. By the way, do you think it's going to be if I was to look at all of them, do you think it's going to be skewed or symmetric? That distribution of all 492 GPAs? Skewed to the left or right? Do you think there's going to be outliers on the left or on the right if you're going to have outliers? Left. Skewed left, yeah. All right. Annie, what do you think? What do you guys say as the... A 3.4? Kate, what do you think? 285. Caitlin? 3.4. Adeline, what do you think? 3.0. What do you think?
Like in between.
Between all those, Jasmine? 3.5. Okay. So if we do, I'm going to set the line. I'm going to say the mean is, let's say 3.5. All right. If I said the mean is 3.5, if that's the line, how many of you guys take the over? Think that the actual is greater than 3.5? How many of you guys take the under? Okay. So let's do the ho-ha. We love the ho-ha. And we're going to say the alternate, the null hypothesis is that the mean is 3.5, but we claim that it's actually less than that, right? Now we have to define what mu is. So mu is the mean GPA of all SHS upperclassmen non-athletes. I have to define what mu is. And in this case, I'm going to define mu to be the mean GPA of all upperclassmen non-athletes at Salem High School. Now, I took a random sample of 40. So I took a random sample of 40. And I actually did this. And when I did, I found the mean to be 3.38 with a standard deviation of 0.613. Notice okay. So this is the Greek letter mu, and in statistics, mu stands for what? The mean, right? And this is x bar, and in statistics, x bar stands for the mean, right? So both of these symbols represent the mean. So the question is, why do we have two of them? So check in with your neighbors and try to figure out why do I have two of them and when do I use which one? Why do I have two of them and when do I use one over another? Who wants to take a stab at this? Who wants to take a stab at this? Tate, what do you think?
X bar is the sample mean, and the other one's like just whole mean.
Yeah. So x bar refers to the sample and mu refers to the population. So if I find the mean of the 492 athletes, I would denote that by mu because that's the whole population of 492 students, upperclassmen, non-athletes. Now, if I take a subset of that, if I take a subset of 40 out of those 492, now I have a sample. I no longer have the population. And the sample mean is denoted by x bar. So mu refers to the population, and x bar refers to the sample, and it's important to know the difference. Right. So we've set up our hypotheses. We have defined what mu is. We've got our sample statistics. I'm going to be doing a one sample t-test for the mean. One sample t-test for the mean. And I need to check 3 conditions before I can proceed. I need to check 3 conditions before I can proceed. So, with your neighbor, go over what you think the 3 conditions are and how are they met. By the way, all 3 are met, and you want to tell him or her how they're met. How are all 3 of the conditions met? Krish, can you tell me one of the conditions? Sample is random. One of the ways to get a random sample from here is to assign a unique number to every single one of the 492 people. Using a random number generator, generate 40 unique numbers out of those 492, and then find the corresponding GPA of all 40 of those, and that's your random sample. Allison, can you tell me another condition and how it's met?
There are more than 400 student non-athletes at the school.
Yes, which means that the
10% rule is met.
correct. How many guys had that? So since there are more than 400 upper class men non-athletes, at SHS, the 10% rule is met, which leaves Henry what?
The sample's larger than 30, so a large count is met.
Good. Yeah. N is equal to 40, which is greater than 30. So large count is met. Now we are ready to do the math. So the calculator menu that you want for this is menu 672. Menu 672. Menu 672, and I want statistics for this. For this one, I want statistics. Wait, I think I got a wrong one. So menu 672. All right. So what do I put in? What's my mu? 3.5, is that what we said? As the null. And this was 3.38, 0.613, with a sample size of 40. What's my alternate hypothesis? Less than? How many of you guys got that? Got those? Got that data? Got that data. All right, so my T is negative 1.238 with a p-value of 0.1115. Now you're not given an alpha for this, and when you're not given an alpha, what should you just assign alpha to be? 0.055%. So since p-value of 0.1115 is greater than alpha of 0.05, is that a small or a big p-value? Big. And with a big p-value, I fail to reject, right? Think of a big basketball player in the paint. Not going to get rejected easily. So, fail to reject the null hypothesis. Fail to reject. Which means fail to reject. Right. Write up the interpretation. Thus, go and fill in the blank there. It's a big blank, but fill it in. Thus, share what you wrote with your neighbor. Share what you wrote with your neighbor.
Since the p-value thus there is not enough evidence to prove that the mean is less than 3.5.
Yeah, I said thus there is not enough information to conclude that the GPA of non-athletes in Salem High School is less than 3.5.
So be careful about using the word prove. You want to use conclude. Like prove is strong, right? But you can make a conclusion, which is not proof. It's just a conclusion.
Okay.
Carter Sr., can you read what you wrote?
Thus, there is not enough evidence to conclude that the true mean value of Salem High School students, upperclassmen and non-athletes, is less than 3.5.
That the true mean,
Value.
you said value? Value of what? GPA. Yeah, you want to. Mary Beth, can you read what you wrote?
I think it's 9.
Caitlin.
Thus, there is not enough evidence to conclude that the mean value of the GPA of all of the Salem High School upperclassmen non-athletes is less than 3.5.
Good. Right. Something to that effect. Thus, there's not enough evidence to conclude that the what? The mean GPA of who? Non-athlete, upperclassmen, and SHS, some combination of those three things, right? Is what? Is less than 3.5. Questions? On a scale of 1 to 5, with 1 being I was completely lost and 5 being I followed this reasonably easily, how was that example for you? Anybody, anywhere? Okay. Okay. It's from Mary Beth. Hello? Sure. No problem. It's not for you. It's for you.
Wait, what?
They want to talk to you.
Me?
Yeah.
About what?
You're about to find out.
Wait, who wants to talk to me?
I think
Oh, the phone.
Yeah.
Okay.
They'll tell you.
Yellow. Okay, yeah. What's the issue? I think it's one end open.
Okay, take a look at this one. Hasta luego. Every road has a construction zone at some point.
Yeah.
That sounds very like something you would see in English, right? Like, what does it mean? Or like a very motivational, right? Listen, all you roads out there, I know you're having a hard time dealing with your construction zone. Just know that every road at some point has a construction zone, and so it's normal. So don't sweat it. Just know that. Put a poster about that. To see if drivers obey lower speed limits posted in construction zones, a police officer uses a radar gun to measure the speed and MPH of a random sample of 10 drivers in a 25 mile per hour construction zone. Here is the data. And you're given data of 10 drivers. Is there convincing evidence that the average speed of drivers in this construction zone is greater than the posted speed limit of 25 miles an hour? Is there convincing evidence that the average speed, that the mean speed of drivers in this construction zone is greater than 25 miles per hour? So let's start with some good old ho-ha. You know it, you love it. So set up what you think the ho-ha is going to be. and then define what mu is. What is mu? Mr. Foster rocking out. Why not? 7th period. If not now, then when? I guess first. All right, mu is, what do you say mu is? 25, right? We're going to assume it's 25, but we're going to try to show, we want to evaluate whether there's enough evidence to show that what? It's greater than 25, right? And what is mu? Mu is the mean speed of drivers in this construction zone. And the test we're going to use to do here, all right, 1 sample or 2 samples? 1 sample. If I'm doing with a mean, I'm going to be dealing with a t-test for the mean. 1 sample t-test for the mean. Working with a mean, thus it's a t-test, and I have 1 sample. I'm going to check the 3 conditions. All right, 2 of them are easy, and the 3rd one's going to take some work. Dakota, can you tell me one of the conditions?
The sample is random.
Yeah, sample is random. Good. Ayla, what's the other one that's going to be more straightforward?
That there's at least. Wait.
Assume.
The sample is large. Oh, assume that there's more than the 10% rule.
Yeah, there are more than how many?
More than 100.
100 drivers in the construction zone. Thus, the 10% rule is met. All right. Now, if the sample size was greater than 30, large count would be met right off the bat. But here it's not. So, Morgan, what do you think we're going to have to do? We have to make a box plot, right? Which means we need to enter the data into a spreadsheet. So start a new document. Start a new document. And add lists and spreadsheets. By the way, make sure that you name your column right off the bat. And put the data in. So put the data in. And we will want to graph this. So once your data is in, what are the steps in making a box plot? I have to do what? add a page to do control documents, which adds a new page. And then I want to add data and statistics. When I add data and statistics, it gives us this random scatter. But if I go to the bottom and I add my variable, it makes it look like this, which is good. And now how do I make a box plot? Menu, 1, 2. Now, okay. I'm going to sketch this. Well, I'm going to say this. N is equal to 10, which is less than 30. So examine a graph. All right. 20, 22, 24, 26, 28, 30, 32, 34. So this one's like here. Then right at 27. Then right at like here, right at 32, right at 34. What else do I need to do? Title. Yeah, make sure to label your graph. So this is, I'll say speed of drivers. And I'm going to add the units, which are miles per hour. Cool. So all the conditions are met. Now what I'm going to do, I already have 2 tabs open. I'm going to go ahead and add a third. And now I'm going to add the calculator. So I've got my data, I've got my graph, and now I'm going to add a new tab, my third tab. I'm going to do menu 672. And now my data input method is going to be data. Okay. Mu sub naught, my null hypothesis is what? Huh? 25, good. My list is whatever you called your data, whatever you called, whatever you labeled that column. And my alternative hypothesis, what's the direction on that one? Greater than. So this is the setup. And this yields a t-value of 3.051 and a p-value of 0.006884. Raise your hand if you got what I got. If you got what I got after putting it in. All right, so test statistic. T is 3.05 and a p-value of 0.006884. All right, so write down your conclusion and interpretation. Write down your conclusion and interpretation.
Does it give an alpha?
I'm going to give you an alpha of 0.01. I'm going to give you an alpha of 1%. A very, very small alpha of 1%. By the way, I'm going to go ahead and put up the problem here. So often the wording from the last sentence is very helpful. Reject or fail to reject the null? Reject, right? We reject the null because the p-value is small. Small p-values get rejected. Okay. So, thus there is or is not enough evidence. There is enough evidence. And by the way, the general pro tip on these is a well-written question will say, is there convincing evidence that blah? And then your answer should be, thus there is enough evidence to conclude that the average speed limit of drivers in this construction zone is greater than the posted speed limit of 25 miles an hour. Right? You can pretty much copy verbatim. Right? Thus, there's enough evidence to conclude that the mean speed limit of drivers in the construction zone is greater than the posted speed limit, or I said posted speed limit of 25 miles an hour. And the posted 25 miles per hour speed limit. But you can pretty much copy verbatim what the question asked. Any questions on this one? Again, on a scale of 1 to 5, give me a sense of how well you followed / understood this one. Okay. By the way, tomorrow I've got data from athletes and non-athletes, and we're going to compare two means. We're going to compare means from two samples. So for that, our null hypothesis tomorrow is going to be that the mean for the athletes is the same as the mean for the non-athletes. And you don't have to write this down. And our alternate hypothesis, by the way, which group do you think is going to have a higher average GPA? You think it's going to be the athletes or the non-athletes? We are going to see if we have enough evidence to conclude that the average for the athletes is greater than the average for the non-athletes. And we will see. But today, we have a couple more minutes. So what I want you to do, you're not going to write up this whole one, but I want to post this. I want you to set up the null and alternate hypothesis for this. And then I want you to find the t value and the p value for this problem.